Well, there she sits on the pad. We had a decent lunch time, 2 o'clock in the afternoon or so. We got up and had some breakfast, and the first things we had to do, obviously, was to get into our suits, get ready to go. Steve was flying for his second time into space. There's Scott, excuse me, there was Steve flying for his second time into space. And again, we can't see. There's Scott. And Pedro, notice Pedro was very serious. He was a rookie, so he was thinking about all this. And Chiaki, full of energy, she was ready to go. Let's get out of town. And then John there, he's all pumped up. Got the suit inflated, checking the pressure check. Once that's all complete, we leave the crew quarters there and walk out to the Astro van to make our way out to the pad. We were really overwhelmed by the number of folks that were outside. You cannot see them, but there was a huge number of folks there waiting to greet us. Now to get into the vehicle, first thing we do is show up at the white room, which y'all have seen, and get on about 80 pounds more equipment, our little comm cap and our harness, and then get in the orbiter. As you see, the orbiter is in the vertical, so you have to kind of do a chin-up to get yourself up into the seat and comfortable. And then we sit there for a couple hours finishing the countdown to liftoff. There's Steve. He's got his equipment now. He's in his seat on the right side. Again, you can see the vertical part of it. Chiaki's already in her seat on the mid-deck. She's nice and comfortable. Steve Robinson's getting into his seat as ILMS number 3, or ILMS 3 seat. John's in the white room getting his harness and stuff ready to go. And finally, Pedro getting his equipment. If you look back in the far left corner of the screen, you can see Pedro behind Steve, and then Scott getting in the center seat, kind of like the commander, bridge commander or whatever. He's got his center seat. He can see everything. They removed the white room there, and we're ready for launch.
About 6 seconds before we launch, the main engine's light, and they get up to speed and make sure everything's working okay. We had a little drag chute door fall off somewhere in here. You can just see in the corner. Just a minor problem, but then the solid rocket boosters light off, and you really shake around in the cockpit when that happens. We'll show that here in a second, what it's like on the flight deck and the mid-deck. There's the jolt, and that's what it feels like. It's a pretty rough ride, going from 1 to 2 or 2+ Gs almost immediately. There's the mid-deck shot. And we launch off. About the time we pass the top of the tower and start turning, we're already going 100, 200 miles an hour. So you get up and go real quick. We turn till we're heads down, and we start heading out over the ocean. As you can see, it was just a beautiful day. There's what it looks like on the inside as we roll around and start going downrange. And we'll ride these solid rocket boosters up to about 150,000 feet the first 2 minutes of flight. Something unique on this flight, we had a camera in the left solid rocket booster that recorded the separation there. We're looking at the external tank, and you'll see that video here in a minute. There's the boosters coming off, and it flashes real good in the windows for us. There's the flash in the windows, so you really know when they come off. And there's the shot of the orbiter flying away, and the solid rocket boosters coming off. You can see they tumble in perfect formation. You can see the Earth below, and actually this video goes all the way down to the water. It's really spectacular to get a chance to see the whole thing. And there they are coming off from the ground cameras. And then it's another 6 minutes, and we hit orbit and 0G. And there's the mid-deck when we hit 0G. And Steve's shaking John's hand. Last thing that happens, the external tank comes off. You can see the bottom's all burned up. All in all, it was a real spectacular, fun ride, and no glitches all the way up to orbit.
As soon as we get into orbit, we want to photograph the external tank as it falls away, and this is what Pedro's doing. His very first couple of minutes in space, Pedro Duque finally gets into space after years of training and took this beautiful camcorder shot of the tank passing over the Earth at a tremendous velocity and then venting out some of the excess gases. The next thing to do is to turn this rocket ship into a orbiting laboratory, and we all got to work down on the mid-deck. John and Chiaki did a little celebrating and got right to work. They did all the work of getting everybody out of their suits, packing everything up. We had about 21 bags down there. Back up on the flight deck looking aft, we opened the payload bay doors so we could get to work with our payloads in the payload bay and also to allow cooling for our electrical systems. If you looked right up from opening the doors, somebody pointed out that we were right over the Hawaiian Islands already. We'd already gone 3/4 of the way around the world, and there's Oahu. To give you a little tour of the payload bay, looking from down from the arm, this is the aft end of the orbiter, obviously. Right up against the aft bulkhead is a collection of astronomy experiments. And then right just before the Spartan satellite, there's some Hubble Space System telescope tests that we took along with us. Then we took a laboratory called the Space Hab on board. You're looking at it right now with the 2 window hatches open, and we got into that through this tunnel from the middeck. And here's how we got in there. Go through the tunnel, floating, of course, which is a great way to travel. Into the middeck, or into the Space Hab module, we called it, and this is our onboard laboratory, or one part of it. Actually, the whole shuttle was a laboratory. And this was actually our first time in it, and I turned around and watched Pedro kind of celebrating the fact that he was in the microgravity or free fall environment for the first time, and he was, as all of us were, having just a great time floating around and also getting to work right away. Going back out to the payload bay, we're looking down from the arm again. You can see that the tunnel and the airlock. We did not do an EVA on this flight, but if we did, that's where we would come out. And you can see the forward part of the orbiter there. That's the part where the crew spends most of the time. The flight deck on top, the mid deck on the bottom, and now zooming into the flight deck here.
On flight day 2, right after we got up in orbit, we deployed the Petite Amateur Navy satellite. It's a small satellite, spring-mounted, that just springs out of the payload bay there. The unique thing about this satellite is it's surrounded by solar panels and antennas, and it's not stabilized. So even if it spins, it still sends a good signal. It's designed for use in ham radio frequencies. So we deployed that in flight day 2, and it worked quite well.
Meanwhile, there were more than 80 experiments for us to work on. And in the next scene, you will see John studying the bone cells of humans, trying to understand osteoporosis, or the bone loss that affects basically older people, especially women. That was one of the experiments we had in the middeck, or the lower part of the orbiter cabin. Through the long tunnel, as Steve said, we could reach floating the other part of our laboratory, our main laboratory, the Space Hab module. There is where most of the science activities took place. This is a furnace in which we melted gradually 9 different rods of very special metals. In that way, the scientists try to understand the laws of solidification in order to improve the processes, the industrial processes that use molten metals like casting. Another example of the very many experiments is this one, in which we studied the production of small quantities of a material called aerogel, which is a very good isolation in 0G. Much of the crew time was also spent in this glove box, this box that you see sticking out the wall. One of the experiments that we performed was one in which we suspended drops of liquid in mid-space and then studied their movement when we applied a heater on one side of it. There were other experiments in the glove box. One of them was this one here, in which we studied the formation of crystals in very special materials. Chiaki is in this scene trying to take pictures of all these crystals before we go back to Earth, because most of those crystals will destroy once we hit the Earth gravity again. So the science had to be collected right then. Some of the crystals, some of the materials forming crystals might be potentially hazardous. So that's why Scott is here making operations inside the glove box using the gloves so as to keep them sealed. And this is an example of how busy the Space Hab was, a very small environment with many people doing experiments at the same time. And this is one of the examples of the facilities. We had 7 of them to create protein crystals.
Stevie Ray and I shared the honors of flying the robotic arm on the flight. Steve was primed for the deployment and retrieval of the Spartan solar observing satellite, and we both flew the arm to evaluate various vision systems in preparation for the International Space Station assembly and beyond. And here you can see us going in for the grapple of the Spartan satellite in the bay, now being carefully lifted up from its V-guides. The arm flies incredibly well, very precise. Some of the tasks on the flight required us to fly to a tolerance of less than 1/10 of an inch, and was able to do that without much difficulty at all. Prior to the deploy itself, Spartan was maneuvered to evaluate the video guidance system, which may ultimately be used to support automated rendezvous and docking on future spacecraft. And here you can see Spartan's grapple fixture pointed towards the sun in anticipation of our deployment. You can also see the gold mylar-covered telescope of the Spartan spacecraft. And basically, it's designed to study the solar corona, or the sun's atmosphere, and the origins of the solar wind, basically the total radiation flux that we receive from the sun, because that's very important in the satellite industry, as well as for space travelers, those people living on orbit and interplanetary travel, rather. Here we are getting ready for the deploy itself. Steve opens up the snares on the arm and very carefully backs away. And we wait here for the next 4.5 minutes. We're waiting to see a 45-degree clockwise maneuver followed by a 45-degree counterclockwise maneuver, and that indicates to the crew that the Spartan is in a proper configuration for its 2-day free flight. Once that's complete, Kurt fires thrusters on the spacecraft, the shuttle rather, and we back away from Spartan for its 2-day free flight. And here you can see it traveling through the end effector camera's field of view. The science team out at Goddard tells us that the solar science mission aboard Spartan was an unparalleled success, and they obtained hundreds of solar disk images like the ones you're about to see. Tremendous images that will help us understand the origins of the solar wind. One of our other primary objectives on this flight was to gain a better understanding of some of the corollaries between spaceflight and the normal aging process. And here you can see John, often confused for the bionic man, getting ready for sleep. And he's wearing a number of special scalp electrodes and an instrumented vest that all told recorded 21 different physiologic parameters during his sleep, and will hopefully help us understand sleep shifting and other parameters on orbit. Another major experiment was the protein turnover experiment, and here you can see Pedro backed into a corner getting ready for another blood draw. And this novel experiment will hopefully help us understand the hows and whys of muscle protein buildup and breakdown. And John processed a number of the samples for us.
Gravitational biology was the other field of interest. Steve is now checking the signals from the fish vestibular nerve and fish behavior. And we had 2 fish on board. I'm giving fish an acceleration stimulus to see the response of the gravity sensing organ and its adaptation process. And also I'm watering the cucumber seeds. We had a lot of plant experiments to see how gravity affects to the plant development and growth. Steve is handling a plant fixation kit. This kit contains liquid fixatives in it, so it has quite a lot of capability. And I'm in the middle deck. I'm opening a portable freezer for plant samples. We also had a lot of experiments on biotechnology, such as cell culture, gene transfer, protein crystals growth, and micro encapsulation, and so on.
As you know, to keep the orbiter running, you have to do a lot of operations every day. Here, Scott's changing out a lithium hydroxide canister. What this canister does is scrub the carbon dioxide out of our atmosphere each day, and we have to change those out. Every morning, we would get up the morning mail, and that would include a new flight plan with changed times on it. Here, Kurt and I are reviewing the plan, and he installs it. We had a record 20 personal computers on board for this mission to handle our science experiments, a lot of our payloads and things. We use them for a lot of things. Here, Pedro actually is writing a letter home. So we used it for email, just like you do here on Earth as well.
Well, the Spartan spacecraft has been out in the free-flying configuration for a couple of days, and that was its design life. So it's now time to power the orbiter back up, get it into configuration to rendezvous with the Spartan spacecraft. And as you see, it's a team effort. We check and recheck every switch. But one of the highlights is when we get Spartan in sight for the first time, and we do that by looking out at the overhead windows, and we also have a sight that we look through to help us with ranging and angles to make sure we're flying the proper trajectory. And another thing we look for is make sure the Spartan is in the correct, or the satellite is in the correct attitude for the rendezvous and grappling with the robotic arm. And again, as you can see, the hot dogs there, Spartan was in a very good attitude. Now we're looking at some monitors that we use and cameras that we use to actually maneuver the orbiter manually up to the spacecraft so it's in a good position for the grapple. And keep remembering that right now the spacecraft is stationary and the orbiter is moving ever so slightly, and it weighs, let's say, about 230,000, 240,000 pounds. So you're looking from the end effector of the camera, and so we're moving that camera, that end effector of the arm, by maneuvering the whole orbiter. It's a very slow, very precise maneuver, and as you see, as we get up close to the grapple fixture, or the point which I need to stop, we'll go ahead and fire the jets. The payload will stop in apparent motion right about there. That stops pretty much. And then I'll tweak it up a little bit, and I'll give it over to Steve.
Once Kurt had put this $250,000 Discovery up next to the 3,000-pound Spartan, then it was Scott and I's job to reach out with the robot arm and make a good solid connection with the satellite after it had been out collecting data. Pretty important to get it back. Not only do we want it back for its scientific instruments, but all the data it collected is on board too. We also used the Spartan for another reason too, for testing construction techniques for a space station. You can see those spots on there. Those are targets for a video system which looks out and determines the location and attitude of the payload to a fairly tight degree of accuracy, and that in fact was used just the other night to help with the first construction stages of the space station. Putting it back in the payload bay was a very delicate operation, and now it's all locked back home and berthed, and we can bring the Spartan back home.
Meanwhile, life in space goes on inside the orbiter also, and here you see Kurt just put something in the oven there to warm up at the galley. Just putting it in now, and then we'll have some food that has to be rehydrated, puts it in for either hot or cold water. If I had my bets, it probably is a shrimp cocktail if I know Kurt. And there I was over in the corner eating, and you have to be very carefully handle the food, put it on Velcro or against some of the duct tape to keep it from floating off in front of you. Instead of old folks spilling things on their neckties, it came up on my glasses. And this is some of the hygiene going on daily. Everyone, close quarters we are, we expected everyone to keep clean and non-smelly. That was some of the exercise there. Took a towel bath after that was over, obviously. And this is Shockey in one of her more somber moods, as you can see. Going at it there, Miss Energy herself, nuclear energy. Someone passed her something to drink, and this is Pedro, who I think has had about enough. He's looking at his watch. He's been on it for at least a minute and a half at that point, I think. And this was getting ready to go to bed in the sleep stations that we had for 3 sleep stations on board because of the sleep experiment. And this is when we're getting ready to go to bed one evening, or get into the sleep station, or not that evening, and shut the door. We took them 2,500 pictures on board, and from the 350 statute miles high that they were spectacular. And we learned a lot as we were briefed on yesterday, and the view from up there, don't let anyone tell you that 28 degrees and a half inclination is bad if you can be up at 350 statute miles, because we had tremendous views from up there and got a lot of wonderful pictures. There's a picture of a Terminator as you go from light to dark. And it's very definite. The light goes down over the side of the Earth from there.
Well, after 9 fun-filled days, the flight director told us we had to come back. We didn't want to. Here we are, we're reconfiguring the vehicle back into an entry vehicle or an airplane. Meanwhile, on the middeck, their job is to get us all in our suits and get all the bags stowed again. Here they're instrumenting John up for one of the medical tests. It's going to monitor his heart rate and blood pressure and things like that as we enter. We start our entry again about 9,000 miles away or so of the Earth. There we are all, or 9,000 miles away from our landing site. There we all are up on the flight deck. Entry was just spectacular. We flew right over Baja, California, and Texas, and the Gulf Coast of Florida, and then right into Florida. There you can see some plasma from the heating. There's the vehicle coming in, and we'll do some roll reversals here. But if you have never been across Baja, California at 40 miles in Mach 24, you just would not believe how fast you go by. It was spectacular. So there we are maneuvering. We get to Florida, and then we'll set up, and at about Mach 1, Kurt will take over manually and fly the orbiter to landing.
Well, other than fixing Senator Glenn's food, as you saw, I did have one other job, and that was landing the orbiter. But we're coming down final here at 300 knots, about 20-degree dive, and the next job is to put the main gear down. Steve does that about 300 feet above the ground. You notice the birds flying around. It's a bird sanctuary, and if you notice the orbiter has a little bit of crab in it, we had a crosswind. And you can see my hand working on the control down there, and that's actually a landing. You see what a landing looks like from inside. And right about there is a little touchdown. Another view from outside, you see the crab in the orbiter also, and down to touchdown. We touched down at 200 knots. That's about 220 or so miles an hour. We didn't have a drag chute this time, but we wouldn't use it anyway because we were doing the crosswind DTO, or crosswind test. So we flew the nose down to the runway, and then we started our rollout with a little bit of brakes. We'll look through the window on Steve's side, the right window. You can see kind of the rollout into orbiter. It's kind of a bumpy thing. And we slowly come to a stop after 4 3.6 million miles and 134 times around the Earth. STS-95 is complete. Discovery then goes back in the OPF in process, and it's already in process for STS-96, which will be coming up later on, or next year, I should say. After they check the orbiter, make sure it's all okay, the crew can get out. We get into crew transport vehicle, and then one of the neat things we like to do is walk around the orbiter. And again, just to show you how big the orbiter is compared to how big we are. And that was our home for the last nine days. And she did a great job carrying us to orbit and bringing us back home. And notice the nose gear is right on the center line for the landing. But